Hello. We're going to solve problem 2140 today, solving questions with Brainpower. I haven't looked at this problem yet, so it's going to be kind of like a first attempt. Um, Hopefully I can find a solution, and this is something I can post. If you're watching this, that means that I posted it, so that means I must have found a solution. Um, let's go ahead and get right into it. So you're given a zero index, 2D integer array questions, where questions of I has points and brain power. The array describes the questions of an exam, where you have to process the questions in order, starting from question 0, and make a decision whether to solve or skip each question. Solving question I will earn you points I, but you will be unable to solve each of the next brain power I questions. Okay, interesting. That's how exams work sometimes, right? Like when I went to Berkeley, sometimes you just want to solve. If you had an exam that was so long that you wouldn't be able to process every single question, the optimal thing would be to find the easiest questions that would take the least amount of time to solve those first, and then solve other questions, right? So in this exam, if you see a problem that doesn't give you that many points, but it takes a long time, it's probably better to skip it, right? Like if this problem's only worth 3 points out of 100 points, and it's going to take half of the duration of the exam, I should probably skip it. But if this problem gives me a bunch of points and it doesn't take that long, then I should probably do this problem, right? So kind of related to something that you've done, except in this, right, you have to go in order, versus, in most exams, that's not a constraint, right? You can look at every page of the exam, do all the problems, and then go back, and if you have extra time, go back and try to solve some of the remaining problems. Okay, you will earn points, but if you're unable to solve the next brain power I questions, if you skip question I, you can make a decision on the next question, okay? For example, given questions equals 3, 2, 4, 3, 4, 4, 2, 5. If question 0 is solved, you will earn 3 points, but you will be unable to solve questions 1 and 2. If instead question 0 is skipped and question 1 is solved, you will earn 4 points, but you'll be unable to solve question 2 and 3. Okay, so I think the easiest way to model this is with the graph. So let's go ahead and do that. So we have questions 0, 1, 2, and 3. So we'll just label those as nodes. So you have question 0. So I'll just label them with the values that are inside of it, so it's easier to distinguish what these nodes are. 4 and 4. I just realized this is going to be a problem. Don't worry about... That was from another problem. I like to put all my problems on one note. That way I can look at everything I've done in the last few weeks. But nobody cares about that. 4, 3, 4, 4. What comes next? 2, 5. Okay, so we have this simple situation where we have these 4 questions. Right, and then the way that this works is, well, you gather points if you do a question, but if you do that question, you have to skip subsequent problems, right? So if I skip a question, I earn 0 points, right? So system starts here. So I earn, put 0. I earn 0 points, right? If I'm at this node and I decide to not execute on this node, I can just go to the next node and earn what? I can earn 0 points. I earn 0 points to go to this next node, versus if I take the points that I get, right, which is this 3 value, I get 3 points, but I have to skip the next 2 questions. Right? If I do that, I get 3 points. So these blue values are the amount of points I get for traversing an edge. If I skip, if I don't decide to take this path, I can take this path, and I would get 0 points. If I decided to execute on this node, right, and I decided to gather the points, I'd have to skip the next 3 questions. Now, there aren't 3 questions remaining, so it would just be like this, right? It would be the end of the exam. This one, I'd have to skip the next 4. So likewise, and likewise here, right? Because I'm skipping over the remaining questions, right? I have to skip the next 4. There isn't 4, so I just skip whatever's left. And if I take these points, I get 4 points. If I take this, I get 4 points. And if I take this, I get 2 points. Right, and I guess there's a path here that's 0 if I decide to skip the last question. So the optimal path through here, of course, you start in here. Now, if I decide to skip question 0 and go here, I could get 4 points here, but that's it, right? Because I skipped past the remaining questions. If I decide to skip this problem and go to the next one, I get 4 points here. If I decide to skip this problem and go to the next one, right, I get 2 points. Or if I skip this, I get 0. Right? If I skip all the problems, I get 0 points, which makes sense. Okay. But if I take the first question, I get 3 points. And then I take the last question as well, I get 5 points. So the best path is then this yellow one, right? All other paths that we just kind of walked through are suboptimal. Right, so how is this going to work? So this is dynamic programming for sure. Because we have this directed acyclic graph, right? And we have to determine if it's optimal to take a question or to skip it. So okay, so for any point, right, like let's just say this graph was bigger. Sorry, I was just thinking if I'm allowed to do that, right? How do we know if it's better to go like this or to go like this? Right? Because that's your 2 choices. Either you skip this question, which is what I'm saying in green, right? Green means skip question, right? Meaning the green highlighting. Or yellow, which means do not take question or answer question, I guess. Answer question. And take points. Okay. Right? So I guess the idea is that for this node that we have highlighted here, right? What we should do is whatever gives us more points, right? So we should skip this question if at this state we have more points than if we took this question and got the points associated with here. Meaning, if we call this, sorry, let's see how we're going to do this. Let's go red. So this was point A. This was point A. This was point B. And this was point C. Okay? What should we do with this question? We should take the points of A. So we can either take the points from A and the points from B onwards, right? So I'm using this colon to say whatever I get after that in the system. Or we can skip this question and take the points onwards from B. This is C, sorry. Damn it. So this is C. Right? So these are the two things I can do. I can either take the points from A and C, which means I take the points from here, and then I get whatever's the best remaining from this point onwards. Or I skip this question and I take the points from B, and whatever the best thing to do from B onwards is, right? Okay. All right, this means B onwards. Not like the rest of the points you can get, but whatever's the best at that point. Right, so that's the best thing to do at any question. The best thing to do at any question is say, at the question that I'm at right now, right, the best thing for me to do is either take this question and get the points I get after I skip the Brainpower questions I have to skip in order to take this question, answer this question, or I skip this question. So whatever's the best thing to do at here is the max of those things, right? It's the max of whatever's the best from this point onwards, or the best including this point and from this point onwards. Okay? So that means that our recurrence relationship for, so let's say D of I, right? Because we have, for any point, we have points at I and brain power at I. That means let's have a array called D, where D of I equals this points idea we had here. Right, so D of I means that D of I is the most points from this point. Let's just call it score, right? Score is the number of points you got. Highest score from this point forward, right? So D of I is at this point, right? What's the highest score we could get? So we neglect what comes before us, right? But from this point going forward, from this question going forward, what's the highest score we can get playing this game of skipping questions or taking questions and skipping brain power questions, right? So what's the highest score from this, not point, I guess, from this question forward? Okay, well, that's what we answered here, right? So D of I for a ith point, right? Let's not neglect this idea. Is, well, either we take the max of, well, what's the first thing we can do? We can either take this question, answer this question, and get points of I. And then that means we have to skip brain power number of questions. So we take points of I, and then we get additional points from whatever the best thing is from brain power I later, meaning I erase this because it's all over the place. Whatever. Right, either I take this question and then I get whatever's the best after I skip a couple questions going forward. Right? And that's what's captured here. Or I just skip this question and I get whatever's the best going forward for the next question, right? Which is the same thing as saying, well, if I don't take this question, then I can consider what's the best for the subsequent question, because now I can consider it since I don't have to skip it, and I don't have to skip it because I didn't answer the question currently. So that's the idea. So we need to populate information to the right? In order to answer this, we have to answer this and this, right? In order to find what's the best for this question, I have to know what's the best for subsequent questions. So we need to process this reoccurrence array in, what the hell was that? In this direction. Right? We need to go from right to left. That way, for any node, we know information about the subsequent nodes to make an answer about what needs to happen. All right, so this is the reoccurrence relationship. And with that, let's just go ahead and get into the problem. Everything got all tangled over here. All right, so So how's this gonna work? I'm trying to think of where there's any way we can cut down on space, but that doesn't seem like that's... Okay, so we'll have this D array that we created, and then it'll be the length of questions, right? All right. It'll be an array that's length of questions. I don't know what I'm doing. I'm a little tired today. Thanksgiving was yesterday, and just, I don't know. Times the length of questions. And then we have to go in reverse, right? So we'll call it I in range, length of questions -1 to -1 in the -1 direction. Don't ask me why Python is like this. So for any question, right, the best thing we can do is what? Either we just skip this question, right? Or we take the points from this question which is questions at I, the 0 value is the points you get, right? Plus D at I plus questions I1, because that would be the Brainpower value. Let's just do this so it's a little clearer. So the power, what am I doing? The points of I and the Brainpower of I equals questions at I. That way it's a little bit clearer what we're writing here. So we take the points of I, and that means we have to skip forward questions. The only thing is that, okay, if I skip 3 in an array, I'm just trying to prove something to myself. So if I'm taking question 1, and I have to skip 2 questions. So I'm at 0, and I skip 2, 1, 2. But I want to skip these 2 questions, so I need to add 3. So +1, +2, +3. So I +1. Now, because I don't want to, if I'm skipping 2 questions, the next question I need to process is 4, right? But if I was 0 plus 2 is 2, would start on this value, but we don't want to consider this value. We want to consider 4. So that means that we skip I +1 in this D array. Plus Brainpower of I. I don't know what this is. Or the other thing. The only thing here now is, though, is we could get a... we could get an index out of range, right? Because this could be bigger than... it could go outside of the range of the array, right? Like when we did this example here... My iPad's down on my side now. Right, when we did this example here, like this skips 4 questions, but there's only 1 question remaining, right? So it would ask like, what's the value of D past this limit? But there is no value of D. So, you know, we could play a... So we can make it length of questions, and then we could add another 0. And then for this, we could make it the max of that and length of D -1. So basically saying, like, if you try to skip over everything, right? If you try to, like, go past the limit, this will just stop it from going outside of the bounds of the array. So not max, but min, right? Because if it gets bigger than that... that's kind of ugly, but it's fine. And then the best thing to do is whatever we're supposed to do at D of 0. Brainpower of I is not defined. It's not. BRAINPOWER. Foolish. Okay, let's submit that and pray. Sorry about my poor explanations today. I'm just very, very tired. See, that's what sucks. Like, imagine today I had an interview and I'm this tired. And if you watch other videos of mine, you'll know that there's variance, right? Some days you have much better energy, you're better at explaining things, you're more articulate, and other days you're not. And that's what can kind of suck about interviews and why it's really just a numbers game, because you could walk into an interview and have a great day and be really convincing, and then you could have another day where you're just not on, and that's just the nature of the game. Okay, so what's the runtime and space complexity? So we only look through, we have one loop, right? And it has questions, number of questions. So let's say n is the number of questions. So we only have to go through that loop once, and then we do constant operations. So that's an n time algorithm, right? I guess this takes n time 2 to build this array. Kind of, so you could say that this is O of, for time, right? This is O of n. For space, I was hoping we could find a way to, I guess you could. You probably could, but it would actually make your runtime worse. So I'm not gonna worry about that. But it's O of n time, O of n space as well, right? Because we have to create an array that's the size of the number of questions, because we have to keep information about subsequent questions. What's the best thing to do? So we need O of n for both. And yeah, that's the nature of this problem. I hope that made some sense. I'm sorry if it was really convoluted today, but you got to do a problem every day. So see you guys.